Numerical number 6. Two resistors having resistance 4 ohm and 6 ohm are connected in parallel. So this is how we can draw the circuit diagram for 4 ohm and 6 ohm. They are connected in parallel. So to find the equivalent resistance, we can use the formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, 1 upon 4 plus 1 upon 6, LCM 12, 3 plus 2, 5 upon 12. So 1 upon Rp is equal to 5 upon 12. Now this is the point where most of the students make mistake. Okay, they write 5 upon 12 as the final answer. Whereas as you can see here 5 upon 12 is 1 upon Rp. So to find the equivalent resistance we must reciprocate the final step. So Rp is equal to 12 upon 5 which is 2.4 ohm. Now since there are only two resistors here, okay, we can use this formula to find out Rp directly, R1 R2 upon R1 plus R2, 4 into 6 upon 4 plus 6, 24 upon 10, 2.4 ohm. Next question. Four resistors each of resistance 2 ohm are connected in parallel. So once again we can use, first we can draw this circuit diagram for four resistors connected in parallel and each resistance is of 2 ohm. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. Remember one thing, that whenever you solve any numerical, the first step must be to write the formula. Then substitute the values. So 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. That is 4 upon 2, 2 ohm. But as I told you in the last numerical, okay, we will have to reciprocate the final step. So Rp is equal to 1 upon 2, that is 0.5 ohm. Now since here four resistors are having same value, we can use the formula Rp is equal to R1 upon N. So this formula is applicable when N resistors of equal value are connected in parallel. So Rp is R1 upon N, R1 is 2, 4 such resistors are connected. So 1 by 2 is equal to 0.5 ohm. Next, you have three resistors 2 ohm, 3 ohm and 5 ohm. How will you join them so that the total resistance is less than 1 ohm? So R1 is 2, R2 3 and R3 is equal to 5 ohm. Now we have to connect them such that the total resistance is less than 1 ohm. So only one possible combination can be there, that is parallel connection, right? Because we know that in parallel connection the total resistance is less than the least value of any resistance present, individual resistance in the circuit. So here the least individual resistance is 2 ohm, right? So if we connect these three resistors in parallel, then only the equivalent will become less than 2 ohm. Let us verify. 1 upon Rp is 1 upon R1 plus 1 upon R2 plus 1 upon R3. So that is 1 by 2 plus 1 by 3 plus 1 by 5. LCM is 30, 15 plus 10 plus 6, 31 upon 30. So Rp becomes 30 upon 31, which is less than 1 ohm. And the circuit diagram is three resistors connected in parallel and then label each resistor 2 ohm, 3 ohm and 5 ohm. Alright, next question. Three resistors each of 2 ohm are connected together so that the total resistance is 3 ohm. Draw a diagram to show this arrangement. So here equivalent resistance is 3 ohm. So first of all we will have to connect two resistors in parallel. So when I connect two resistors in parallel, equivalent resistance will be R1 by number of resistors here 2. So 2 upon 2, 1 ohm. And then with this parallel combination, I will connect the third resistor of 2 ohm in series. So that final equivalent resistance becomes 1 plus 2, 3 ohm. And that is our answer. Numerical number 10. Calculate the equivalent resistance between the points A and B in the figure below if each resistance is of 2 ohm. Let me first label each resistor here R1, R2, R3 and R4. Now as you can see here R1 and R2 are connected in series. Okay, so R1, R2 will give us the series connection. R3 and R4 they are connected in parallel. So first we'll find out the equivalent resistance of the series connection. Then we will find out equivalent resistance of the parallel connection. Okay, so let us first find Rs, that is R1 plus R2, 2 plus 2, 4 ohm, and for parallel connection Rp is equal to R3 by 2, 2 by 2, 1 ohm. Now these two Rs and Rp, how are they connected? Rs 4 ohm and Rp 1 ohm, they are connected in series with each other. Series. So to find out the final equivalent resistance, we must apply the series connection formula 4 plus 1, 5 ohm.
Thank you for watching. Please check the link in the description below for more numerical videos. Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.